Hi everyone, thanks for joining. Today we're going to talk about local GenAI. So this is the new series where I'm going to have four sessions and we are starting with local rack. The approach is going to be as usual. We'll cover basic concepts with the help of technologies and then we'll have some demo. These sessions are basically kept at a very high level, mostly around concepts, so that anybody who's joining can really get an understanding and be benefited. Now, I give demos to generate confidence and have a practical view of things that I cover. And I'm happy to take it to the next level if you require more in depth details in terms of coding, implementation, configuration. I use Azure platform mostly for running GenAI models from OpenAI, but my session is essentially uh, not specific to any model or platform. I use open source frameworks, languages, and tools. The idea being is anybody joining this can really learn and implement in any platform of their choice. So the LinkedIn group called iMantra that I basically use to publish um, the market and technology trends. Feel free to join if you have not joined already. This is the fourth series. I had three series in the past. I've got recordings of all those sessions available. These recording links are also included in the invite that I've sent to you for this series. Feel free to go through them. Let me know if there's any question or any topic that you would like to discuss. So let's get down to the topic of the day, which is running local Gen AI. Now we know ChatGPT has ushered in a new era of using Gen AI, but Gen AI or the language models comes with some limitations as well. For example, uh, the data that the model is not trained on, if you ask questions, it will try to make up, providing you an inaccurate response. And sometimes the response that it generates is not explainable, and which is sometimes very important for critical business use cases. These language models, whether it's large language models or small language models, they are basically trained on publicly and available web contents, social media posts, books, data sets, scientific literatures, and they sometimes have only very generic knowledge. And it may just be possible that some of the data that the model is trained on may have some biases. These language models also have a cutoff. They are trained on a data set uh, which is recent as up to a certain date. And most importantly, language models do not have access or to data which is coming out of real-time systems or applications or private data, which is very important factor in order to run Gen AI use cases in enterprises. Now, these problems can be addressed by a pattern called retrieval augmented generation. Retrieval augmented generation is basically an architecture which augments models' knowledge by retrieving information from different knowledge sources before a response is generated. So it's basically um, retrieval before generation, and the benefit is that it addresses most of the concern that we have just seen. The retrieval provides the grounding data on which the model can base its response, and that addresses most of the concern we have seen just now. For enterprise solution, uh, this is basically very useful because now you can constrain the generation aspect based on the data that you have from what is called vector databases. And we'll see that in detail. So if you look at the diagram below, so you have a prompt that is augmented by a retrieval to generate a response, and that really is all about the RAG. And I had two more sessions in the past on retrieval augmented generation. Today's focus is more about how we can implement RAG locally. That means you run your solution on local infrastructure, assuming that you have an uh, AI grade infrastructure. Uh, by AI grade, I mean you have GPUs, a lot of memory, uh, and faster disk, so that you can benefit from the local implementation. And let's see what are the benefits. So the most important benefit is data privacy, because you are running the models locally. All the grounding data, the prompt and the response is not going to leave your network. You can be assured about data privacy if that's a bigger concern. It will also enable a faster response because you would have uh, your model running locally and inference execution happens on your network. You can customize specific to your needs with the data that is coming out of your knowledge sources, from your applications running online data, and that provides a more current and relevant response for enterprise use cases. Since you are running these model locally, so you really don't have to pay a token based cost that you generally pay for hosted models, and you have control over the data quality as well. Now, what all you need to run the model locally? So you have open source models. These models are available for you to use, but how do you run it? And so let's look at these tools and frameworks that can enable execution of your GenAI solution locally. One of the useful tool called Olama. So it's an open source tool for running and customizing large and small language models on your local machines. It supports various models. It in fact supports almost all the open source models like Llama 3 from Meta, Mistral, Gemma from Google, Phi 3 from Microsoft. It provides you both a command line interface, which is a chat like interface where you can actually ask model by providing a prompt and get a response. And also, if you have application that requires access to the inference over an API interface, that is also possible. You pay nothing because you're using your own infrastructure, and it has all the benefits of running models locally that we have just discussed. So let's see what is there in Olama. Go to olama.com and you can download this application, which is available for Mac OS, Linux, and Windows. Once you download the setup file, just execute that and you'll have that Olama application running. You can actually go and see what are the models which are available, and you will also get to know how you can run those model after downloading. Say for example, if you want to download and run Phi 3, you have this command olama run Phi 3. So let's go and see how it works. So I've got some models already downloaded to save time. So I've got one, two, three, four models downloaded. And in order to run that, I have to just simply provide the command Olama run the model name, which is Llama 3.2 here, and that's it. Now, if the model is not available locally, it will first download that model, validate the integrity of the download, and then instantiate this model. So, very easy chat like interface, and that's how you run local models using Olama. Toolkit is another tool that you can use. It is an extension to Visual Studio Code, and that enables you to not only play with these models but also run it locally and embed GenAI capabilities in your application. And let's see that. The other tool that you can use to run language models locally is an extension to Visual Studio Code called AI Toolkit. So you can go to the extension section, download it, and once you install it, what you see is this AI Toolkit icon. And when you click that, you are presented with options that are there for AI Toolkit to use. The categories are where the models are hosted, the publisher, kind of device you have, whether you have CPU, GPU, whether you want to run locally or remotely. Now, depending on the model that you choose, you are able to not only just download it. So here, if you see, there's a download button, whereas this is already downloaded and I'm able to use that very easily by just loading into a playground. That's a chat-like interface that Visual Studio AI Toolkit extension provides. And it is loading the model in the memory. Once the model is loaded, so I'm using Mistral 7B, and then you can simply prompt anything that you require the model to work with. Very simple, very easy. You can provide a system message here. You can set parameters like temperature, top free, and this is also accessible over an API interface, and that not only allows you to test this model before you actually use it, it also helps you write application that can leverage GenAI capabilities in language models. Another very useful tool to run language model locally is LM Studio. It's a desktop application where you can actually experiment with local and open source language models. Um, Now, this allows you to run language models entirely offline and privately, and that's a really good feature. And let's see LM Studio. Studio is also very useful software that is available for Mac, Windows, and Linux. You can go to lmstudio.ai to download the setup. Once you install LM Studio on your machine, you can actually see it launches into the home page, which gives you an option to search the model catalogs which is available. You just simply press download button and the model will be downloaded for you to use locally. Once installed, you have option to run it locally in a chat based interface, or you can launch model as a server where the inference API will be available for you to call over HTTP if you are running it through an application. And we'll see LM Studio in more detail. Look at LM Studio in more details. So if you go to the My Models option, you will see all the models which have been previously downloaded. Go to the local server options. Here you can actually instantiate a language model and expose its inference endpoint as an API. In order to do that, select the model which has been previously downloaded. Unlike Olama, here you have to download the model first and then use it. So you choose a language model, and once it gets loaded, it will be exposed over an API endpoint, and you should be able to call that API to get that inference function done. So you see the server is running on HTTP localhost port 1234. And since we are running lag, we also need another AI model called embedding model. We are using Nomic. So let's load that model as well. Now we have all the tools and application that we require to run GenAI locally. Let's see how the RAG would work. Now, before we actually get into the code and everything, let's understand how RAG works. Now, you can see the RAG involves a grounding data to be supplied before you uh, generate the response from the model. And in order to do that, what you require is the knowledge that would be used to ground the model's response. And the knowledge can come in different formats as PDF files, HTML, doc, text files. And when you prompt the model, the grounding data may not come for the entire data that has come from the knowledge source. And also models have a fixed size context length. In order to do away with this limitation, you basically chunk that knowledge base or these documents into smaller parts, and these parts are then embedded. Embedding essentially is converting the knowledge which is there in a chunk and converting into a vector multidimensional form that is easy for search. And the kind of search that you perform is a semantic search. So you chunk it and then you index the vectorized form along with the original content in a database called vector database. Now please note, this stage has to be done before you start prompting uh, the model. So once the vector data is ready, which is stage A, B, C, D, now you start asking models some questions. Here, what you have basically as part of this workflow, your prompt will be also embedded, and that embedded prompt will be used to perform a similarity search. And as a result of the similarity search, you will get a subset of the knowledge, and that knowledge, that subset of knowledge, along with the prompt which was originally provided by the user, would be used to generate the response. Now, this response in RAG would be grounded on the result of the search that has been performed over the database. And what you get is a much more accurate and much more grounded response on the information that you have provided as part of ingestion and indexing process. And we'll see how it is implemented in the code. Look at the code. Let's understand the RAG process flow in a bit more detail. So the first stage is chunking. So you basically break down the large text or document into smaller, more manageable pieces. And that basically helps to overcome the context window size. You can have fixed size chunks, variable size chunks, or custom chunking. Essentially, what you are doing here, you are converting the knowledge which comes from various documents into smaller size of information, and that then gets embedded, which is again a machine learning technique that basically represent your knowledge or data as a multi-dimensional numerical array with capturing the semantic relationship and similarity. And that's the key. And these chunks then gets embedded and stored in the vector database. That is basically the flow for ingestion and indexing. The data then gets into the vector database and you perform a search on this database when you are prompting the model to generate a response, and it will basically retrieve a relevant chunk and supply it for the model to generate the more accurate response. And that retrieval, uh, there are a number of techniques. The most popular is called cosine similarity. It is basically um, how two vectors are closely related in an n-dimensional vector space based on their meaning, and that provides an accurate uh, input for the model to generate the response. And we'll see that practically. Visual Studio. I've got two Python code files. The first one is populate database, which is the ingestion and the indexing flow. So what I'm doing here, I'm basically loading the documents, splitting into multiple chunks, and then using embedding to get a vector representation of each chunk. And then I'm going to be using another Python code, which is basically implementing a chat-like interface where the user inputs would be taken and then the prompt would be embedded to perform a similarity search to get the semantically relevant chunks out of the vector database, and this information would then be fed into the Gen AI model, language model for generation. That's how things would work. Let's just run it and see. Now, I will also, while running this, I'll also show you what goes behind the scene. Remember, we have loaded a language model and an embedding model in LM Studio here. Now, when you run and ask a question, who is Tarun? So, what is happening behind the scene? This prompt is embedded, and the information which is supplied in the vector database, which was all related to a project that I did with other information related to my colleagues. Uh, that information is what I've supplied as a knowledge base for demo purpose. And then what I'm doing here, essentially implementing the RAG pattern. If you go back, so the question was who is Tarun, and based on the given context, it has retrieved the chunk that had some relevance to my question, and then based on that grounding data, it has created a response. Now it is not only generating the correct information but also providing you the source, and that basically covers the explainability aspect, which is very important. Now what happened behind the scene, if you see, let me start from the beginning. So my question was, who is Tarun? And that embedding model nomic was used to embed that question, and then there was a retrieval done. So this block of text was semantically similar, and it had information related to me somewhere, and that information, see who's Tarun and all that, and that was used as the grounding data for the model. So now this is model is generating response um, progressively. This is basically how language model works, and in the end it is basically generating a response grounded on the retrieved data, which is what we see here. Now all that is running locally, and that's the point that I'm trying to demonstrate here through this session, that you can run language model locally, both embedding as well as language model. You have to just write some code, uh, or you may find some application which has this implemented and has a very user friendly interface. I had to, take help to code this, and that's how you implement model locally. Let me just show you this in action. Um, Say for example, and I'm just trying to ask very basic question. And let's see, when I ask this question, what goes behind the scenes? So here you will see you can actually see now it is generating a response for the question called who is Subruto, and what it has done basically similar to what we saw earlier. um, it basically who is Subruto is will embed the question, uh, and then identify the relevant chunk and then supply it as a grounding data, and what you get is a response with references and citation to the original source. And that's how you can implement uh, RAG locally. Obviously you require much faster processor. um, my laptop has a basic GPU. What you require in order to run an enterprise grade RAG application locally is a machine with lot of memory, disk space, and GPU, and you should be able to run locally. That basically is what we have just seen in this demo. Was the demo on a RAG which is implemented locally. So let's summarize what we have learned today. Um, as you've seen, RAG enhances the performance of language model by connecting the generation part with the knowledge that has been obtained from an external data source or a knowledge source, and that helps in providing a more accurate and the relevant response. You can implement RAG locally. Um, you can have open source model running on your local hardware, and that provides you higher privacy, a better response time, negligible cost, assuming that you have the infrastructure already in place. You can use Olama, LM Studio, and Visual Studio Toolkit to run this model locally. You can use an embedding model to basically first uh, chunk the large knowledge source into smaller manageable chunks, embed it, and then store it in a vector database so that when a prompt um, is looking for some relevant information, that information can be retrieved, which then can be fed for the language model to generate a better response. Thank you for attending this session today, and I'll see you in the next session. Goodbye.